The Kirby-Bauer assay, or disk diffusion assay, is a test used to determine whether a microbe is sensitive to an antibiotic, meaning that the antibiotic will inhibit its growth, or whether the microbe is resistant to an antibiotic, meaning that the antibiotic will inhibit its growth. It's so easy to do. So often it's the first line of testing one does to determine whether a microbe is sensitive or resistant to an antibiotic. There are other tests that can sometimes provide much deeper, more meaningful data, but take a much more work involved, right? So once again, the disk diffusion is often what we do. We're going to use two types of antibiotics. One that comes in a solution, so I have various antibiotics there, and then we can also use these commercial discs. Each of them have these are typically the standards, so in a clinical lab, these are what we use, but we're limited to the discs that we have, so we'll also do it the old-fashioned disc way, okay? So take your plate and label it, all right? Of course, your initials, your date should be on there, and then I like to mark each section with the antibiotics I'm going to use, so sulfanilamide, sulfamethoxazole, cefotaxime, clindamycin, and tetracycline. If you want to and you don't want to write all this stuff, you just go 1, 2, 3, 4, and then in your notebook you can write what 1, 2, 3, 4 is. And then here I have my cultures. Ideally you want them in isolated colonies, right? But I don't have these ones isolated, so I'm just going to use S1 here, and that's mostly for my interest. And then you're going to need 2 swabs. This pack here contains 2, and we're going to use both TSB, pipette, and then we also have sterile discs and forceps just off the screen here, and you're going to have your biohazard or biowaste disposal nearby. Okay, so first things first, we need to inoculate our broth, and there is a certain standard that we have to use, right? So ideally they say use 3 to 4 normal size colonies, right? So in this case, because I don't have, I'm just going to pick some. Oops, you guys didn't see that. Just take some. All right, and then flame, and then I'm going to stick that in my broth, and then just swirl to get the bacteria off. And you want there to be a very low level of cloudiness. Avoid too much splashing. There are these standards. This is what they call the McFarland standard that you have to compare to. But they barely look like. They pretty much look like water. So. Remember, this is our bacterium, so that goes straight in the discard. I'm going to close that off, and there we are. Can you tell the difference between this and a sterile broth on the video? Probably not. Even in real life, it's just a minor turbidity. So if you want to do this properly, you should get it to an exact measurement, right? But since we're going to go approximate. That'll be sufficient for us. Some is better than none. Too much is probably better than none. So we have some. Okay. Next thing I'm going to do is I'm going to make a lawn, and a lawn is important because we want to make sure our bacteria are covered very evenly throughout the whole plate, right? So very quickly, I'm going to give it a mix. I'm going to do that off camera now so I can get it closer to me. I'm going to grab my second swab, and then insert into my inoculated broth, touch, and turn. So I'm pushing this against the glass. I'm just turning to squeeze out any excess liquid. Flame, I'm going to put that away. And then now I'm going to make my lawn. All right, and the lawn starts by going from the top and then covering the whole plate all the way from top to bottom, making sure I cover everything. I don't want to go back on my own lines, but I do want to go all the way down and cover everything, not these broad stuff like that. Point isn't to get to the bottom. Point is to paint the whole thing. Then I'm going to turn it 90 degrees, and I'm going to do it again. Just like that, all the way top to bottom. And I like these grid lines because they help me orient myself. I'm going to do it one more time. All the way. Notice I'm going all the way to the edges. And also notice I have to change the angle of my plate as I go down because it gets more difficult. And then finally a 4th time. And if you're good at math, 4 times 90 is 360. And if you're excellent at math, that is a circle. One little swirl around the edge. And that's done. This, discard. Okay, so let's do this, right? So ideally, we'd like to have a separate container for your discs that you can work on, right? But because we don't have that option, we are going to do it the old-fashioned no-budge way, right? So the discs, the sterile discs come like this. You can just open that up, and then we have these ejectors, which I don't happen to have on camera, but that's okay. And you just pop out a disc or two, right? And then you get yourself these sterile discs. And then we will need our forceps right here. Our forceps are an ethanol. Gentle touch. And then we want to burn our fire off, right? Pass once. Pass twice. Careful, don't hold it in there because it is hot, right? It is metal, so it's going to heat up. And then I'm going to take my disc and I'm going to put that on the lid of my plate, just like that. Again, not the best way to do things, but it is good enough for now. Right? And then I'm going to put that back in there. And then I'm going to add my antibiotic to that. 10 microliters, so it should read 100, right? A black 10 and a red 0. And then I will load, guess how much? 10 microliters of my antibiotic. So I'm going to take, let's start with clindamycin. So I have, that's chloramphenicol. I don't have that on there. I have clindamycin. And I'm going to first stop. Make sure you're in the liquid, right? And then nice and slow. That's 10 microliters. I'm going to put that away. And then I'm going to slowly, can you guys see that? Squirt that onto my disc, just like that. All the way out. And then eject. And then now that disc will have clindamycin soaked into it. Okay? Now. And you could do all your discs on the plate like that first. But then, because they're not labeled and because they're sort of anywhere on the plate, remember the plate turns and all this kind of stuff, I'd rather do it one at a time, right? But it's, it's your world. Do what you want. Now I'm going to take my disc. I like to put my finger on where I want to put it. So I'm going to put it in my clindamycin spot. Put it right on top of my finger. Gentle push. And then that'll stick. Just like that. That's disc number 1. Okay. Let me show you how to do, let's use, what's this one here? This is my sulfamethoxazole. This one here, a little bit different. This one comes already impregnated with the antibiotic. So, once again, burn that off, right? You want to keep things nice and sterile. And then pass through twice. Careful, it might get hot. I'm going to push this to the side. A little bit of a challenge, but try to, push that out, right? My sulfa is, because it's already loaded, I'm just going to stick that on there, on my finger, and then done. Sometimes what happens is as you're going, you accidentally drop your disc. If you happen to drop it there, you have to leave it. Don't drag it. Don't leave. Don't do anything. And then if you can, adjust your other discs so there's as much space as possible in between them. But if you're stuck with it, then you're stuck with it, right? So obviously, wherever it touches, that's where it's got to stay. That's it, right? And then we're going to put 4 different antibiotics on there. So we have a selection of commercial antibiotics. We have a selection of liquid antibiotics. Choose any 4 that you like, place that on your bacterium, and then you're good to go. And then tomorrow, on the next day, we will see the results. And remember, if there's a zone of inhibition around the disc, that means the bacterium was unable to grow near that disc, right? The antibiotic has diffused out of there, right? So that bacterium then will be sensitive. That means that antibiotic is effective against the bacterium. If the bacterium is able to grow right up to the disc, or there's a really small zone of inhibition, right? That means that bacterium is not really affected by it. It means it's resistant to that antibiotic. That antibiotic is not useful for therapeutics.